Hello everyone, and welcome to all of you to our channel Schrödinger Cat. And this is basically Devaprata here. So we will cover the live session, the JEST 2024 question. So first of all, we will cover here the JEST 2024 question paper conducted by the SERB, Science and Engineering Research Board, and basically the IIST Bangalore, the Indian Institute of Science and Technology, IIST basically in the Thiruvananthapuram. So first we now discuss the exam pattern. In the exam pattern, the basically part A, part B and the part C. In part A, there are 25 questions and carrying 1 marks each. This is equal to 25. In part B, there are 15 questions carrying 3 marks. This is the 45. And in the part C, there are 10 questions net. This is carrying 3 marks, so equal to 30. So the total number of questions in the JEST exam, that the 50 questions and carrying 100 CR. Okay, 50 questions carrying 100 marks and the 3 hours. Now that the exam pattern, first the mathematical methods. There are 9 questions. Classical mechanics, 9 question. Electromagnetism and the optics, here is basically 5 to 6 questions. And the quantum mechanics, this is basically 8 to 9 questions. Thermodynamics and statistical physics, this is from 7 to 8 questions. And the ELT, electronics, there are 5 questions. So almost this is basically the 5 to 6 question, plus for optics there are 3 to 5 questions. Okay, this is for optics and this is for the electromagnetism. So this is the exam pattern, is basically the 50 questions cover here. So we now go through the JEST solution full papers. The first question. Okay, let's get started. The first question, 1 mark MCQ. 3 equal charges plus Q are placed at the corner of an equilateral triangle. The test charge consented to move on. The plane of the triangle is placed at the center of the triangle. Which of the following statement about the test charge is true? A, B, C, D, 4 option. And I just clarify one thing. You first read the question carefully and try yourself first, and after look upon my whiteboard for the solution. So first of all, you just try yourself and give me the answer by commenting. This is the more suitable way for the live discussion class. Okay, try yourself. This is just theoretical based questions. Just apply the theoretical concept. Just apply theory and do the answer. Okay. Just apply the theoretical concept. This is basically here stability of the equilibrium depends on the sign of the test charge. It is a stable equilibrium. It is not an equilibrium. It is an unstable equilibrium. Which options are correct? Sorry, which option is correct? This is for one answer type questions. MCU. This is from the electromagnetic theory. Okay. So here one thing that this is the triangle for solution. This is one triangle for the total charge is negative. The QT is negative. And here another triangle where the total charge is positive. So here suppose this is the test charge plus Q and the plus Q. So here this is the centroid, that also the QT, and the force apply here, this one for this charge and that one for this another charge, and this is the another direction F. And here the resultant, this centroid, the plus Q and the plus Q, here this is in the F, and the another this F. This is the resultant of parallelogram. So let F be the force on plus Q charge due to other charge, and Ft be the resultant force. This is the Ft, and here this is the Ft due to test charge Qt. This is the test charge, means the Qt. Okay. So the system will be equilibrium if the net force of any charge Q is 0. So stability of the equilibrium depend on the sign of the test charge. This will be the correct, because the system will be in equilibrium if net force of any charge is 0. Statement option A would be the correct answer. Next, go ahead. Question number 2. A classical system has the following action. A is equal to integration q dot square plus alpha q dot plus beta q square q dot dt, where the q is generalized coordinate and alpha beta are the constant. Which of the following statement is this true about the dynamics of the system? This is another conceptual question. Try yourself. Okay. Here the Lagrangian is given that here the Lagrangian is given L equal to q dot square plus alpha q dot plus the basically the beta q square q dot. This is the Lagrangian. So first the del L del q dot, this is equal to twice q dot plus alpha q plus the beta q square. Okay. Now time derivative ddt of del L del q dot, this will become twice q double dot plus the alpha q dot plus twice beta q dot. Okay, and the del L del q, this will become the alpha q dot plus twice beta q dot. Okay, so the Lagrangian equation of motion, that the q double dot equal to 0, it is independent of alpha and beta. Okay, independent of alpha and the beta. This will be the answer. The dynamics means the equation of motion is independent of alpha and the beta. Option A be the correct. Next, question number 3. A and B are two Hermitian matrices. Get A1 and A2 are two linearly independent eigenvector of A. Consider the following statement. If A and B are eigenvector of B, then the commutation of AB is 0. If AB commutation 0, then AB are eigenvector of B. Mark the correct option. This is for the quantum mechanics. So here given that, so suppose the let, just a minute. Okay, plug my laptop into the charger. Just 1 minute. Now done. So that here the let, the A acting on A1, that is equal to the lambda 1 kt1, and the A acting on A2, this is equal to the lambda 2 kt2. And also for the B acting on A1, this is the beta 1 A1, and the B acting on A2, this is the beta 2 A2. Okay, so now commutation of AB acting on A1, this is basically AB acting on A1 minus BA acting on A1. Okay, this is equal to beta 1A acting on A1 minus, put this value lambda 1 put this value lambda 1B acting on what? A1. This is equal to beta 1 lambda 1 ket A1 minus, this is equal to what? Lambda 1 beta 1 acting on A1. So this is equal to 0. Okay, so statement 1 is true because A and B are the eigenvector of B and the commutation of AB is 0. Okay, commutation of AB is 0. Here we get acting on A1. And the statement 1 says that the A1 and A2 ket are the eigenvector of B. This result shows that the A1, A2, K and the eigenvector of B and the commutation of AB is 0. Okay, next question. Question number 4. An ideal gas, and I just download the question from the JEST official website because the question is too smaller. So you just resolve the high resolution video for more clarification of the question readout. So an ideal gas initially at pressure P1 undergoes the following sequence of the process: a reversible adiabatic expansion that doubles its volume, a reversible isothermal compression that restores its original volume, a reversible isothermal expansion that doubles its volume, a reversible adiabatic compression that restores its original volume. If the final pressure of the gas is Pf, which one of the following statement is true? Pf equal to Pi, Pf greater Pi, P less Ei. The relation between Pf and Pi depend on the initial condition. Try yourself. This is from the thermodynamics. Very conceptual questions. I just draw a diagram. This is basically PV diagram. This is origin. Here this question says this. Okay, this one. So this is basically V and 2V. And the here this is the A, B and the C point. A, B and the C. Here the Pi, P initial equal to P final. This is the 1. This is the statement 4. This the statement 2. Because a reversible isothermal compression that restores the original volume. And the statement 3 is here. This path in this direction. Okay. Numbering ABC. So now, following 4 processes are involved. Reversible adiabatic expansion. V2 to V. Reversible adiabatic. First one. V2 to V. Reversible isothermal. 2V to V. Reversible isothermal expansion. That is V2 to V. And the reversible adiabatic compression. This is 2V to V. So these 4 processes are presented on the PV diagram. Note that on the same PV diagram, dP dV, this is for the adiabatic, is equal to dP dV gamma times, this is for the isothermal. So adiabatic curve is more steeper than the isothermal. Another important statement. So in the first step, reversible adiabatic expansion, that V2 to V, and the pressure changes from P initial, that is PA, to PB. This is for the statement 1, or you just write statement A, this one. And the second step, reversible isothermal compression, this is for basically V2 to V. And here the second case, 2V to V, system moves from B to C with relatively lower slope. And in the third step, reversible isothermal expansion, system retraces path CB and reaches break at B with the pressure PB. In the fourth step, retraces BA by the following reversible adiabatic compression, 2V to V. So the final pressure PF, that would become what? This is for PA. This is a PA means the initial pressure PI. So our statement that the final and the initial pressures would be the same. Option A is correct because this is round over, and in this step 2D to V, reversible adiabatic compression that restores its original volume, that the final pressure is PA. So PA means what? PA means the initial pressure, this one. So P final would be the initial pressure PI. Option A would be the correct. Next question. Question number 5. A quantum oscillator with the energy level n plus half h cross omega is equilibrium at a low temperature T, so that the occupation of the all states with n greater equal to 2 is negligible. So now the question is that what is the mean energy of the oscillator of the function of the inverse function, that's beta 1 by kb. This is basically the beta means the inverse temperature. Okay, 1 by kt. what is the mean energy of the oscillator of a inverse function temperature. So now, given that En n plus half h cross omega, here the n equal to 0, 1, 2. Occupation for n greater equal to 2 is negligible. Negligible means occur at 0 and 1. Okay, occur at 0 and 1. So the E0 is h cross omega by 2 and the E1 is c by 2 h cross omega by the given statement. So the partition function for the average energy, you should calculate the partition function. The partition function is Q equal to exponential minus beta E naught plus e to the power minus beta E1. This is equal to e to the power, put this value beta h cross omega by 2, and for another e to the power minus 3 beta h cross omega by 2. Okay, just do common here. So e to the power minus beta h cross omega by 2. So within bracket 1 plus e to the power minus beta h cross omega. Okay. So take ln both side. Ln q equal to ln e to the power minus beta h cross omega by 2 plus ln of 1 plus e to the power minus beta h cross omega. So this just add you. This will become minus beta h cross omega by 2 plus ln of 1 plus e to the power minus beta h cross omega. To average energy. So average energy means the E average. This is nothing but minus del beta of ln q minus del beta of partition function. This is the definition, mathematical definition. So minus del beta of q, put this value of q, that the minus beta is cross omega by 2 plus ln 1 plus e to the power minus beta h cross omega. Now calculate. So this would become the h cross omega by 2 plus 1 by 1 plus e to the power minus beta h cross omega within bracket minus common here. This would be the minus h cross omega e to the power minus beta h cross omega. Just calculate. So this would become the h cross omega common here, and within the bracket half plus inverse of e to the power beta h cross omega plus 1. This would be the correct answer. So option A is correct. H cross omega into half plus inverse of 1 plus exponential beta h cross omega. Okay. Option A would be the correct. Next, go ahead. Question number 6. A particle moving in a one dimension that the wave function psi x equal to exponential minus alpha into x minus I k naught by alpha whole square sin square k1x, where the alpha is real positive and k naught and k1 are real. The expectation value of momentum is what? Expectation value of the momentum. Okay. So now try yourself that the given equation psi the psi is given psi of x, the exponential minus alpha x minus I k naught by alpha whole square sine square k1x. This is nothing but the exponential of minus alpha into x square minus k naught square by alpha square minus 2I k naught by alpha into x. Okay, sine square k1x. So this is equal to the sine square k1x exponential of minus alpha x square plus k naught square by alpha plus 2i psi k naught x. This is equal to what? The sine square k1x into e to the power minus alpha x square plus k naught square by alpha within bracket into e to the power twice I k naught x. So expectation value of the momentum. Expectation value means the p average. In quantum mechanics, the average is deal with the expectation value, that the minus infinity to infinity psi star momentum means minus I h cross del del x psi dx. This is nothing but this one, that the psi p psi by psi psi. This is the p average. So minus infinity to infinity psi star psi dx normalization. Put this value. This is equal to minus I h cross 2i psi k naught constant, limit minus infinity to infinity. So sine to the power 4 k1x square e to the power minus of minus alpha x square. This will be the plus, minus go inside, k naught square. Just put this value dx, and here the minus infinity to infinity sine to the power 4 k1x 2 minus alpha x square plus k naught square by 2 dx. Okay, so now solve this, and this is home task. You will solve this integral. Okay, you would get the value 2i twice h cross k naught. The integration should be done for a better practice yourself. The value would become the twice h cross k naught. Just a minute. Okay. The integration value would be twice h cross k naught. Option A would be the correct. Next question. Two classical particles moving in the three-dimension interact via the potential v equal to k x1 square plus y1 square plus x2 square plus y2 square plus z1 minus z2 whole square, where k is a constant and the x1 y1 z1 and x2 y2 z2 are the Cartesian coordinate of the two particles. Let p1x, p1y, p1z and the p2x, yz be the component of the linear momentum of the two particles, and the L1x, yz and L2x, yz are the component of the corresponding angular momentum. Which one of the following statement is true? So here the momentum of z component. Momentum of z component means the Lz. Sorry, momentum of first L1 with the z component. This is the x py means the x1 p y1 minus y1 x p1. So here the Hamiltonian p1 x square p1 y square by 2 plus p2 x square plus p2 y square divided by 2 plus k into x1 square plus y1 square plus x2 square plus y2 square plus z1 square plus z2 square minus 2 z1 z2. Now commutation of L1z with Hamiltonian. This will be, put this value x1 p y1 and the y1 z plus p y1 x1 plus p x1 square divided by 2 okay, minus y1 px1 x1 square into k minus px1 within bracket y1 py1 square divided by 2 So solve, this would become 0. Similarly you will get for the L2z with the Hamiltonian, this would also commute, means 0. And the commutation of P1z plus P2z with the Hamiltonian, this will be always 0. You will check. So L1z and L2z, one thing is that are conservative. Option A is correct because L1z, L2z are conservative, means L1z with the Hamiltonian commute, means the L1z and L2z are simultaneously measurable. And for P1z and P2z with the Hamiltonian is always 0. So it will be the conserved. Option A is correct. Next question. A cylindrical rigid body has the principal moment of inertia I about the system axis and the 2I about each of the perpendicular axes passing through the center of mass. At the some instant, the component of angular momentum about the center of mass in the body fixed principal axis frame LLL. What is the cosine of the angle between the angular momentum and the angular velocity? Question number 8. So now, this is for the 3D moment of inertia. So solution is that the L is defined here. I omega, where the component of L in 3D matrix, this is for 2i and the off diagonal elements are the 0. And the omega x, omega y, omega z. So that imply omega x is 1 by 2i and the omega y 1 by twice y, and the omega z is 1 by I. So the angular momentum, the L is Lx cap Ly cap plus Lz cap, and the omega is 1 by twice I x cap 1 by twice I y cap 1 by I z cap. So the cos theta, because you have to find the angle, that the L dot omega divided by L omega, put this value. This will be the L square by twice I plus L square by twice I plus L square by I. It is square root of this L square plus L square plus L square into L square by 4I square, L square by 4I square, L square by I square. This would become 2 root 2. Calculate 2 root 2 by 3. 2 root 2 by 3. Cos theta means the cosine of the angle. That is the 2 root 2 by 3. Option A is correct. Next. Consider a mass pulley system shown in the figure. The height of the block are measured from the ceiling are x1 and x2. What is the constant between x1 and x2? So that here this is the x1 dot, and this equation of motion, this is for the x2 dot. This is T2 late. Okay. This is T1 and this is also T1. Now the equation of motion T1 equal to 2T2. That means the T1 x1 dot plus T2 x2 dot, this is equal to 0. So or twice T2 x1 dot, this is another equation of motion, plus 2 to T2 x2 dot, this is 0, or twice x1 dot plus x2 dot equal to 0. That means ddt of twice x1 plus x2, this is equal to 0, or this is equal to twice x1 plus x2, this is the constant. Twice x1 plus x2 is constant. Option A is correct. Okay. Twice x1 plus x2 is constant. Next, let Q and P be the canonical phase space coordinate of a system where Q is the generalized coordinate and the P is the generalized momenta. Let us make a transformation for the generalized coordinate as Q equal to capital Q equal to small q square. Which one of the function is canonically conjugate to capital Q? Question number 10. Here, this is that the commutation of P by twice Q with capital Q. This is nothing but P by small q with small q square. This is equal to 1 by twice q. Put this value P q square. This is equal to 1. Therefore, q equal to you just put 1 by 1 option, check which is 1. So capital equal to small q square. So p by twice q is canonically conjugate to q, means AB is 1. Commutation of AB is 1. This is for the canonically conjugate. Check 1 by 1. Canonically conjugate. I just took first option and let us check. Okay. So here the option is correct. P by twice q. Next question. A solid sphere of radius r has a volume charge density rho equal to rho naught sine 2 theta. How does the leading term in the electrostatic potential depend on the distance r far away from the charge sphere? So now that just calculate. So here this is a solid sphere. This is the r, and here this one is rho equal to rho naught sine 2 theta. Okay. So according to multiple expansion, the potential VR equal to 1 by 4 pi epsilon naught. This is the 1 by r integration over V rho r dash d tau dash plus 1 by r square integral over V r dash cos theta dash rho r dash d tau dash plus dot dot. Okay, this is the multiple expansion form. So or integral over V rho d tau dash, this will become 0 to r 0 to pi theta limit, phi limit 0 to twice pi in 3D. This is the rho naught sine 2 theta dashed into r square sine theta dr dashed d theta dash d phi dashed. So this will become rho naught r cube by 3 into twice pi integral 0 to pi theta integral 2 sine square theta dash cos theta dash d theta dash. So this will become 0. After integral, it will become 0. So or integral over V r dash cos theta rho d tau dash equal to 0 to r 0 to pi 0 to twice pi r dash cos theta into rho naught sine 2 theta. This is r square sine theta dash dr dash d theta dash d phi dash. So this will become the V r dash cos theta rho d tau dash. This is equal to rho naught into. Okay. So you have check for where this will not be 0. That the r to the power 4 by 4 into twice pi 0 to pi twice sine square theta into cos theta. Okay, d theta and d phi, and this integral will not be 0. This is 0 and this will not be the 0. That means the potential is proportional to 1 by r square. Okay, this will not be 0. That means the potential inversely proportional to the r square or proportional to the 1 by r square. Option A is correct. Next question from the mathematical physics group theory. Let Z0 be the operation be a discrete group of order 4 where the group operation 0 among the various elements of Z equal to E, A, B, C is given by the following multiple table. Which of the following statement is correct? So G and O is non-cyclic and abelian. This will be the correct. Because this is simple theory. In group theory, non-cyclic and the abelian, the property that says that operation of the group with an element is the remains unchanged. Okay, here EABC, the off diagonal element are the same. Okay, option A is correct. Z and the zero operation is non-cyclic and abelian. Next question number 13. Consider a Fourier transform of a function fx defined as gp, this one. Which one of the following is correct? Form of gp with some constant beta. So let us calculate that the gp is integral minus infinity to infinity 1 by mod x e to the power ipx dx. So let the mod x equal to t square. That means the plus minus dx is equal to twice t dt. So gp is proportional to integration minus infinity to infinity 1 by t e to the power ipt square. Put this value minus twice t dt is proportional to integral minus infinity to infinity e to the power ipt square dt. Okay. So as the integral minus infinity to infinity e to the power minus x square plus bx dx, this is equal to what? Square root of pi by a exponential minus b square by 4a. This is the standard integral. That means the a equal to ip and the b equal to 0. That implies that the gp is proportional to square root of pi by, put this value of a, that the ip, and the put this value of b, that is 0. That will be the beta by root p. That means the beta is constant. Beta is constant. And the value of this will become gp is equal to, we just get here, that the beta by square root of p. Okay, option A is correct. Next question. Which is the power of the light source emitting photon of wavelength 60 nanometer in the rate of 1 photon per second? Short question. Question number 14. So here, simple, that lambda equal to 600 nanometer and the dn dt, this is what? 1 photon per second. So p equal to dn dt hc by lambda. This is the formula. This is equal to ne divided by t, and this is the u by t. U means this is basically the energy emitted per second, u by t. Energy emitted per second. Put this value. This is equal to 1 into 6.6 10 to the power minus 34 into 3 into 10 to the power 8 divided by 600 nanometer 10 to the power minus 9. So this will become 3.3 into 10 to the power minus 19 watt. Option A would be the correct. Next, what is the right sequence of the optical component to convert unpolarized light to circular polarized light? Very important question. We already discussed in polarization chapter. The light source, linear polarizer, and the quarter wave plate. Okay. That the ray diagram here, this is the source, unpolarized light, that the linear polarized with the PPL, plane polarized light, that the quarter wave plate, it will become the circular polarized light. Okay, option A would be the correct. Light source, linear polarizer, then the quarter wave plate. Next question. Where does the Fermi level of an N-type semiconductor lie? Theoretical conceptual question, just near the conduction band minima. Near the conduction band minima. The Fermi level of an N semiconductor lie. This is from the semiconductor physics. Next, question number 17. That a step index optical fiber has the refractive index N1 and N2 in the cladding region. This is given. A ray of light source is incident from the earth to the core through the cross section of the fiber of an angle theta with the normal. What is the limiting value of theta below which the light ray will be totally internally reflected? So for internal reflection, the theta A, that is equal to sine inverse, just apply the formula, square root of n1 square minus n2 square. Put this value, sine inverse square root of 1.474 whole square minus 1.470 whole square. This should become approximately 6.229 degree. 6.229 degree. Okay. Next, a satellite of mass 200 kg is placed in elliptic orbit around the Earth with the same major axis A. Assume that the total energy of the orbiting satellite is E and the angular momentum is L. Through a series of nanocurves, elliptic orbit is changed to a circular orbit when radius is capital A. For the orbit change described, which of the following statement is correct? Basically, that the diagram here, this is for the circular orbit, very important. This is for the circular, r equal to A. And this is for the elliptical. Here the effective, this one, and this is for the r direction. Here this one converted into that one for the elliptical orbit. Here this is the V minimum. This is basically the E. Here the V minimum is the E. This is the A. And the effective potential energy here, the V effective. Here the L2 square by twice mr square divided by K by R. And here the effective potential energy, V effective is L1 square divided by twice mr square minus K by R. So in both cases, energy is equal to what? Minus gmm by twice A. But the angular momentum will be different, as can be observed from the plot of the effective potential. This is basically the effective potential versus R. Very important. So E does not change, each constant, and but the angular momentum is changed due to orbital angular momentum is changed due to the effective potential energy. Option A is correct. E does not change, but L is changed. Next, which of the following function is not a valid thermodynamic function of internal energy U in terms of the energy entropy S, volume V, number of particle N, U naught alpha beta A B C are the constant. Very big calculation. This is basically you calculate. So you just check one by one. Okay, check one after another. Not in U is a function of SVN. Check one after another. So now du del U del S ds del U del V dV del U del N dN. So du equal to TdS minus PdV plus mu dN. So you would get the value of the T del U del S at NV and the pressure del U del V at the Sn constant and the potential, chemical potential del U del N at constant Sv. So thus the U function of U, S, V and N be a perfect differential. Perfect differential. So for perfect differential, you would get the del P del S at NV equal to del T del V at Sn. This is one. Del mu del S at constant Sv. This is equivalent to this. This is basically okay. Del nori del mu del S at constant Nv equal to del T del N at constant S and V, and the last one is del mu del V at constant Sn would become minus of del P del N at constant Sp. This is the general treatment. Now you check one after another option. Okay, that check option B. This is given AV square divided by N exponential beta Vn by A square. So now for checking, T will be what? Del U del S at constant N and V. Put this value here and calculate the pressure. And the next minus P is del U del V at constant S and N, and mu is defined as the del U del N at constant S and V. Put this value and check. You would get the final summary. That means the minus of del P del S, just the perfect differential. We not do here the calculate because time is more consuming. This is not equal to del T del V at constant Sn. You would get the summary, this one. So thus U is not a perfect differential. This is not equal to means what? U is not perfect differential. U is not perfect differential. That means the AV square by N into exponential beta Vn by A square is not a valid thermodynamic potential, because you have to check the perfect differential. Perfect differential means in the mathematics, suppose U is defined as the m dx plus n dy. Perfect differential means del m del y equal to del n del x. You have to check this for all four options, and here the option B would be the correct. AV square by N into exponential of beta Vn by A square is not a perfect differential. Next question, question number 20. What is the output waveform of the circular of the circuit for the given input signal? Assume that the Zener diode are identical. Amplitude of the input voltage is Vin is twice the Zener breakdown voltage, and the RL is 10 R. Simply solved. Positive half cycle. That D1 to F it means the diode 1 is in the what bias? Forward bias, and the diode 2 is the reverse bias. This is the positive half cycle. So here let the VZ break down. That means the VR is 0. That the Vin is less than VZ. That diode 1 is in forward bias, and D2 is in the reverse bias. Means the op. Okay. Zener is not breakdown region. That the circuit would become this is the RL, this is the R plus minus, and here the V output is V input. And for the negative half cycle, V in greater than Vz, D1 is in forward bias, and the D2 is in the Rn reverse form. This is basically the on. So Zener in breakdown region. Here Zener is the breakdown region. That means this is the R, V in, minus, this is for the V out is Vz, this is the RL, and here this is the 0 volt, this is the Vz. So the same logic can be applied with negatively polarity. That means here D1 reverse bias and the forward bias. So option A would be the same. This is basically the clipping circuit. Okay, clip. Clipping circuit, option A be the correct. Next question number 21. Given that the latent heat of a liquefaction of 80 calorie per gram, what is the change in the entropy when the 10 gram of ice at 0 degree Celsius is converted into the water at the same temperature? Ice to water, 0 degree Celsius means what? 273 Kelvin. Simple. The del S is del Q by T. This is for ml divided by T. This would become the 10 into 80 divided by 273. This is equal to 2.93 calorie per Kelvin. 2.93 calorie per Kelvin will be the correct. Next question number 22. Consider a system of n non-interacting spin-half atoms subjected to a magnetic field with the Hamiltonian is given by A is equal to minus G mu B B summation I1 to n SIZ, where G the dimensionless Lorentz factor, mu B Bohr magneton, B is magnetic field strength, and SIZ Z component of spin with ith atom. The system is in the equilibrium at temperature T. What is the probability that the Z component of the spin corresponding to two given atom have the same value? Question number 22. Simply solve this. The possible arrangement of the spin is Z1, Z2, SZ, and the Hamiltonian is minus G mu B given B I1 to 2 SIZ. For the plus half, here the plus half 1 minus G mu B and the mu. Plus half minus half 0 0. These are the combination. Minus half plus half 0 0. And last for minus half minus 1 Z mu B B. So the partition function Q is 2 plus e to the power minus beta Z mu B B plus e to the power beta G mu B B. Now there are two arrangement microstate where two atoms have same spin. Corresponding probability P plus half 2 microstate. So this will become the e to the power beta G mu B B divided by Q, and another arrangement for the minus half this will become e to the power minus beta Z mu B B by Q. This is the probability. So net probability, total probability, that the PT, just add on P plus half spin plus P or minus half spin, add this on. So here the total partition function, that the Q equal to 2 plus e to the power minus beta Z mu B B plus e to the power plus beta Z mu B B, and add 1 e to the power beta Z mu B B plus e to the power minus beta Z mu B B. This will be the total probability PT. Okay, option A is here correct. Next question. Question number 23. Two electrons have orbital angular momentum quantum number L1 3, L2 2 respectively. Let Lz L1z plus L2 z. How many linearity independent states have Lz quantum number for m equal to 2? So now for L1 3, m1 value minus 3 minus 2 minus 1 0 plus 1 plus 2 plus 3. L2 equal to 2. M2 is what? Minus 2 minus 1 0 plus 1 plus 2. So since L1z equal to Lz since Lz equal to L1z plus L2z, therefore it means that the m equal to m1 plus m2. The possible value of m1 and m2 for m2 equal to 2 are permutation m1 3 and to m2 m minus m1, that put this value 2 minus 3 minus 1, and for m1 for 2 for m1 2 you would get the value of m2 2 minus 2 0. For m1 1 m2 value is what? 2 minus 1. This is for 1. m1 is for 1 is over, so m1 is 0, m2 is 2 minus 0, that the 2, and for m1 minus 1 last one, m1 for minus 1, m2 will become 2 minus of minus 1, that 2 plus 1, that the 3. These are the following combination. So 4 combination. There are 4 combination. That is the linearly independent states of LZ quantum number m equal to 2. Option A is correct. 4. Next, a quantum particle is subjected to a potential Vx equal to x plus bx square. What is the mean position of the particle in the first excited state? Very interesting question. This is the beauty of the physics. What are the mean position of the particle? Try yourself first. Simple. Potential given is Vx x plus bx square. So that is equal to, you have to form in square form. Okay, square form, x square plus a by bx. A b just common here. We make it in square form, that x plus a by twice b whole square minus a by twice b whole square. That is nothing but b into x plus a by 2b whole square minus a square by 4b. The potential can be interpreted as a harmonic oscillator potential. This is interpreted potential x naught. This is given by a by 2b whole square. That means minus a by 2b. So the mean position is basically the shifted. The mean position, basically the interrupted position. This is x naught. This will become minus a by twice b. Minus a by twice b. Option A is correct. Next question. Question number 25. The density of states of the system of n particle at energy is given Gen 1 by h cross omega to the by n, e to the by n minus 1 by n minus 1 factorial for e greater than equal to 0, and this is 0 for e less than equal to 0. Taking Kb to the Boltzmann constant, compute the temperature of the system of energy E. We have to done the temperature of the system. G is given. So simple formula, S equal to Kb ln omega. Put this value of omega. G means the number of microstates, omega. Kb ln 1 by h cross omega to the by n, e to the by n minus 1 divided by the n minus 1 factorial. That means S equal to Kb ln, C is a constant, e to the by n minus 1. So 1 by t, that the del S del E, this will become Kb divided by C e to the by n minus 1, C into n minus 1, e to the power n minus 1 by e. This would become, after calculation, the Kb by e n minus 1. So the temperature would become E divided by, inversely, so you just inverse E divided by n minus 1 Kb, that is approximately E by n Kb. Okay, because n is very large, E by n Kb. Option A is correct. E by n Kb. Next, part B, MCQ. plus 3 marks of each. 15 question. The energy spectrum for a system of spinless non-interacting fermion consists of n plus 1 non-degenerate energy level. Let x equal to exponential minus epsilon by kt. For n identical fermion, the thermal equilibrium at temperature T, what is the average occupy the highest energy level? Very interesting and calculating. So I think we just solve here the part A 25 questions elaborately, and I think this is for the homework 1 for your better practice, concept and the understanding. Homework 1, you just do yourself and give me feedback by writing the answers in the comment box, and here option is given, A would be the correct. Next question. Question number 2. A two-level quantum system has the Hamiltonian H equal to H cross omega 0 1 1 0. At t equal to 0, the system is in the state psi 0 1 0. What is the earliest time t greater than 0, which is a measure of sigma z 1 0 0 minus 1 will yield the value minus 1 with the probability 1. So here the eigenvalue and eigenvector of the Hamiltonian H cross omega naught 0 1 1 0 are lambda 1, that is the plus H cross omega naught, and the lambda 2 minus H cross omega naught, and the eigenvector ket phi 1 1 by root 2 1 1, and the ket phi 2 1 by root 2 1 and the minus 1. Thus the state psi 0 1 0 can be written as psi 0 equal to C1 ket phi 1 plus C2 ket phi 2, where C1 is what? Phi 1 psi 0. This is the 1 by 2 root 2 1 1 1 0. This will become 1 by 2, and the C2 phi 2 psi 0 1 by root 2 1 minus 1 1 0. This will become 1 by root. Now time evolving, the state at the time t, so this psi t would become e to the power I h t by h cross, time evolving state, okay, psi 0. This is 1 by root 2 exponential minus I omega naught t phi 1 I omega naught t phi 2. This will become 1 by 2 exponential minus I omega naught t plus exponential plus I omega naught t, exponential minus I omega naught t minus I omega naught t. The eigenvalue and eigenvector of sigma z, eigenvalue plus minus 1, and the eigenvector ket chi 1, 1, 0, and the ket chi 2, 0, 1. So psi t written in the form that the d1 chi 1 plus d2 chi 2, where the d1 means chi 1 psi t and the d2, this is what? E to the power minus I omega naught t plus e to the power I omega naught t. And for d2 equal to that the chi 2 psi t, just calculate, minus I omega naught t minus I omega naught t. When sigma z operate on psi t, the outcome will be plus or minus 1. Now for probability for minus 1, outcome is minus 1. Okay, that mod d2 square, this will become what? Exponential minus I omega naught t plus exponential I omega naught t mod square. This will become 1 plus 1 minus twice cos omega naught t. This would become twice sine square omega naught t divided by 2. Okay. So p at minus 1, this would become 1. Therefore, twice sine square omega naught t by 2, this is equal to 1, or the sine square omega naught t by 2, this is equal to 1 by 2 half. So, or the omega naught t by 2, this is the pi by 4, that imply the t equal to pi by twice omega naught. Pi by twice omega naught. Option A is correct. The measuring time will yield the value minus 1 with the probability p of minus 1 at the time. This would become pi by twice omega naught. Pi by twice omega naught. Option A would be the correct. Next question. Question number 3. The singular matrix A is 2, 3, 3, 3, 6, 3, 3, 3, 6. Commute with the matrix B 1, 0, 0, 0, 0, 1, 0, 1, 0. The eigenvalue of A are what? Question number 3. Simple concept. Sum of eigenvalue. Summation of eigenvalue, that the summation of lambda equal to trace of the matrix, trace of A. This is equal to 2 plus 6 plus 6, that is equal to 14. So here the combination would become 0, 3 and 11. Okay, 0, 3 and 11. Option A is correct. Next, a polynomial Cnx of degree n defined on the domain x belongs to -1, 1. Satisfy the differential equation 1 minus x square d square cn dx square minus x dcn dx plus n square cn equal to 0. The polynomials satisfy the orthogonality relation integral -1 to 1 sigma x cnx cmx dx equal to 0. For n not equal to m, what is sigma x? This is basically legendary differential equation. Check one after one option. I arbitrarily check option 1. Here this is the legendary differential equation. So cnx, this legendary polynomial. Legendary polynomial. Okay. So c naught x is 1. c1 x is x. c2 x is half of 3x square minus 1. And the c3x, that would become half of the 5x cube minus 3x. Now let us check for n not equal to m. Check option A, that I equal to integral -1 to 1 minus x square to the power minus half c naught x c1 x dx. This is nothing but integral -1 to 1 x divided by root over 1 minus x square dx. Now substitute the integration 1 minus x square equal to t square. That means the 2x x dx equal to dt. Put this value x dx equal to minus t dt. That means the integral would become in the form that the 0 to 0 minus 1 by t dt, because we just do variable change here. X dx to dt means the x to t variable change. So the integral would become 0. Satisfy the function. So 1 minus x square to the power minus half would be the correct option. Next, question number 5. Consider a particle of mass m and non-zero angular momentum L. Subjected to a central force potential Vr equal to k ln r, where k is a positive constant. What is the radius r at which it can have a circular orbit? Will the circular orbit be stable or unstable? From the classical mechanics, stable and unstable equilibrium. Simple. First, the effective potential, V effective. The V effective is L square by 2 m r square plus k ln r. Now, the del V effective del r is 0. That means minus L square by m r naught cube plus k by r naught. This is equal to 0. That means it would become the r naught value, that L by square root of km. Now second derivative, del square V effective divided by del r square. Okay, so this is equal to CL square by m r to the power 4 minus k by r square. That means the del square V effective divided by del r square at this value of r equal to r naught, that would become 2mk square divided by L. This is greater than 0, and second order derivative at the point r equal to r naught. This is greater than 0 means this is the stable equilibrium circuit. Stable equilibrium. And the circular. Stable and circular. Option A is correct. R equal to L by square root km, and this is stable. Question number 6. Consider a particle of mass m moving in a 3-dimensional delta function potential well. Delta r minus alpha del q bar. Which one of the following is an allowed expression for the energy of a bound state for some dimensionless proportionality constant? Here, dimensionless means since the bound state of the energy are always negative, so B and D are not correct. Simple, B and D, because the bound state of energy are always negative. Energy of the bound state is always negative, less than 0. Now we have to check option A and C. Have different dimensions. Therefore, correct option can be obtained by checking the dimension. So let us assume the del 3r, or it is written in the form d of del 3r. Okay, this is equal to dimension L to the power minus 3. Now, d of Vr, this is equal to what? M L square t to the power minus 2. So, d of alpha is equal to m1 L square t to the power minus 2 is divided by L to the power minus 3. So this would become m1 L5 and t minus 1. So in option A, that the dimension of the energy, so dimension of minus beta h cross to the power 6 alpha square m cube. Okay, so m L square t minus 1 to the power 6 divided by m square L10 t minus 4. So this would become m1 L square t minus 2. So option A is correct. Simple. Class 12 concept. Next, question number 7. A particle with energy E greater than 0 is incident from the right on a one-dimensional potential composed of the delta function barrier at x equal to 0 and hardware x equal to minus a. Vx is defined alpha delta x for x greater than minus a and infinity x less than equal to minus a. Let us define k square 2m e by h square, h cross square, and the dimensionless quantities zeta is k and the beta h cross square by 2m alpha a. For some energy E, the particle reflects from the barrier without any phase shift. Which of the following translated transcendental equation? Transcendental equation means the equation with the trigonometric sine, cos, exponential function, that one. Determines its energy. Note that in the presence of the delta function barrier, the derivative of the wave function has the discontinuity at x equal to 0. That means the psi 0 plus minus psi dash 0 minus equal to psi 0 by BA. So here this is barrier. This is delta function. This is infinity minus A, region 2, region 1. This is the 0. Here x and the here energy. That means the A. Here the energy E greater than 0. Now apply the Schrödinger equation in region 2. Okay. Schrödinger equation in region 2, that the d square psi 2 dx square plus twice m e divided by h cross square psi 2, this is equal to 0. That means the psi 2 equal to a exponential ikx plus b exponential minus ikx. The psi 2 can be also written as in this form a sin kx plus b cos kx. And in the region 1, this is for the region 2, and the region 1, that the d square psi 1 dx square plus twice me divided by h cross square psi 1, this is equal to 0. That means the psi 1 equal to c cos kx. Apply the boundary condition. The BC x equal to minus a, psi 2 is 0. That means psi 2 is 0 means a sin kx plus b cos kx equal to 0. That means you get the tan k equal to b by a. And at also psi equal to 0, psi 2 is equal to psi 1. That means the b and the c arbitrary constant are same. So at the discontinuity x equal to 0, that the psi dash 0 positive minus psi dash 0 negative. This is what? This is the discontinuity relation given as the psi 0 by beta a. Put this value, or ck sin 0 minus ak cos 0 plus bk sin 0. This is what? B by beta a, or minus ak equal to b by beta a, that the b by a equal to minus beta k. That is equivalent to tan of k equal to minus beta k, because the epsilon is k given. So therefore the tan of xi is equal to minus beta xi. Tan xi equal to minus beta xi. Option A is correct. Tan xi equal to minus beta xi. Next question number 8. The speed of distribution of molecule of an ideal gas is equilibrium at inverse of temperature minus kBT is found to obey the Maxwell distribution. PV equal to CV square exponential minus beta NV square. Where m is the mass of the molecule and c is the normalization constant. Compute v to the power 4 to the power 1 by 4. v to the power 4 to the power 1 by 4. So now just calculate. Here given that first v to the power 4, next to the power 1 by 4. That means the integration minus infinity to plus infinity. V to the power 4, just put this value pv to the power pv. Okay, basically the average, divide the minus infinity to infinity pv. Just do the integration, that the integral part 2 integration 0 to infinity v to the power 4 pv divide by 2 integral 0 to infinity pv. This is nothing but integral 0 to infinity v to the power 6 exponential minus beta mv square by 2 dv. Okay, divide by the integral 0 to infinity v square e to the power minus m beta mv square by 2 dv. This is the equation number 1. Next, the integral, standard integral as 0 to infinity x to the power m dashed e to the power minus alpha x to the power n dx. This is the standard integral that would become the 1 by n square root of m dashed plus 1 by n, okay, divide by alpha to the power m dashed plus 1 by n. Here the arbitrary constant alpha, that the beta m by 2. This is the standard integral. Put this value v to the power 4 average. Put this value of alpha beta here, you would get this result 15 kt by m square, kt by m whole square. Now for v to the power 4 to the power 1 by 4, that means just 15 kt by m whole square to the power 1 by 4, that would become square root of 15 kt by m whole square root. Now check the option. Option A is correct. Root of square root of 15 kbt by m. Question number 9. A classical particle undergoing simple harmonic motion is confined to a region minus AA on the x-axis. If a snapshot of the particle is taken at a random instant of time, what is the probability that it would be found in the region A by 2A? This is basically wave and the optics topic. If x equal to a sin theta, then the integral pi by 6 to 5 pi by 6 d theta means the omega t, that equivalent to 4 pi by 6 is equal to twice pi by t into t, or t by capital T equal to 1/3. That means the probability P is equal to t by t. This is the 1/3. 1/3 would be the correct option. Option A. Next question. The ratio of the molecular specific heat of an ideal gas gamma is CpCv ratio 3/2. It undergoes a reversible isothermal expansion in which its volume doubles. Next, it undergoes a reversible isochoric process such that the change of entropy of the second process is equal to the change in entropy in the first process. What is the ratio of the final temperature to the initial temperature? So now this is the ray diagram here. PV. Okay. P and the V. This one. Process 1 and 2. This is the del S. And here the del S2. Del S1. Okay. This is A and the B. So first process is reversible process AB isothermal. Reversible process AB isothermal, that means the first process V2 twice V del S1. Second process del S2 such that del S2 equal to del S1 because this is the isochoric process. So now calculate the del S1 equal to del Q by T, classical, means nRT ln 2V by V divided by T. Okay, so this would become R ln 2. Let the n equal to 1, that means the del S2 equal to integral B to C. Here this is the C point. ds. So this is equal to n Cv dt divided by T. So this would become n Cv ln T final divided by T. That would become the Cv ln T final by T. Now put this value. Cp by Cv equal to C by 2. So Cp by Cv equal to 3 by 2. And that means Cp equal to 3 by 2 Cv, and we know the Cp minus Cv equal to R. So here you just calculate the value of the Cv would be twice R and the Cp would be thrice R. Now check that as the del S1 equal to del S2, that is equivalent to R ln 2 equal to twice R ln Tf by T. Put this value. So Tf by T, that would become R ln Tf divided by T whole square. That means the Tf divided by T square root of 2. Square root of 2, option A is correct. Next question. Question number 11. Two trains is having proper length L0 are moving toward each other with the same speed V but in the opposite direction as measured by the observer is an inertial frame. Which is the length of one train as measured by an observer in the other train? Special theory of relativity, classical mechanics. Simply, velocity addition theorem and the length contraction formulas are the applied here. V1e, that is the V1, and the V2iz, this is for the minus V. So thus, the V12 by the velocity addition formula, V minus V divided by 1 minus V minus v by c square. So this would become twice v by 1 plus v square 1 plus v square by c square. So L12, this is nothing but the L0 square root of 1 minus v12 square by c square. Okay. So this is equal to L0 square root of 1 minus 4v square by c square is divided by 1 plus v square by c square whole square. Okay. So, or it would become the L12 is equal to L0 c square v square divided by c square plus v square. Option A would be the correct. Next question. Question number 12. An infinitely long cylindrical of the radius r has uniform volume charge density. A spherical region of radius r is kept out on it as shown in the figure. At what volume of r is the electric field would be the maximum? Due to a possible alternate interpretation of the question, both option A and B will be treated as correct answer. This is declared by the JEST authority. Question number 12. That let us assume charge density of cylinder is rho and the sphere is minus rho. This is the charge density rho and here the minus rho. So field outside the cylinder E1 for the cylinder, that is rho r square, is divided by twice epsilon naught r cap, and for the sphere this the E2, that will be minus rho r cube divided by 3 epsilon naught r square r cap. This is for the one for the cylinder and another for the circle sphere. So E1 plus E2, just add them, you would get rho r square divided by twice epsilon naught r minus rho r cube is divided by thrice epsilon naught r square r cap. For maximum value of E, the mathematical condition that d dr is equal to 0. Derivative here and take 0. Rho r square by epsilon naught constant outside. So 1 by 2 r square plus twice r by c r cube. You would get the value of the r, that the 4/3 r. For maximum value of E, Emax means the second order derivative negative, d square E dr square less than 0. That means you just do the second order derivative d square E dr square at this value of r equal to 4/3 r, you would get the negative result. So it should satisfy. So option A and B both are the correct, because r equal to 4/3 r and r equal to r by the convention. Question number 13. What is the output of the following logic circuit? This question is withdrawn since the level are not shown in the figure. All candidate will be awarded plus 3 marks, because here are not given any figure, any notation. So this is withdrawn from the question, so we just not solve here. Okay. Next question, question number 14. What is the value of the integral 0 to infinity dx 1 by 1 plus x cube dx? This is basically the standard form of 0 to infinity 1 by 1 plus x to the power n dx by the complex variable method. I hint you, you solve yourself. You already solved in your MSc for BSc complex variable chapter. You just choose a contour here. Okay. For this integration, this is very useful for choosing a contour complex integration method. This is the C gamma. Here this is B and the A. And already you just know 0 to infinity 1 by 1 plus x to the power n dx, and put here n equal to 3. And the option would be twice pi by 3 root 3. A would be the correct. This is the homework number 2. Solve yourself and feedback the answer by comment. What is the output voltage and the current in the 10 kilo ohm resistance of the following circuit? Question number 15. Last question of part B. So here I means what? Vi minus 0 divided by 10, that means 0.05 milliampere, or basically written the 50 microampere. And the output voltage V0 I into R, simple, that means minus 0.05 into 25. This would become the minus 1.25 volt. So the V0 minus 1.25 volt and I equal to 50 microampere. So we now complete the part 1 and part B section in the JEST 2024. Now go ahead the part C section. Numerical answer type plus 3 marks each. There are only 10 questions. A system of two non-interacting identical boson in the thermal equilibrium at temperature T. The particles can be in one of the three states with non-degenerate energy value minus E 0 epsilon. The temperature T such that exponential minus epsilon by kT is half. The average energy of the system is found that minus n by 35 epsilon. What is the value of the n? What is the value of the n? Numerical answer type. Simple. First, the diagram. N equal to 2 boson, non-interacting and identical. So the number of the accessible microstate, that is equal to, this is the state 1 epsilon. This is for epsilon. Epsilon state, 0 state, and the minus epsilon state. Okay. So here the epsilon, that twice A, single A, this one. For 0, this is twice A, and the A. And for minus epsilon, the twice A, this is the configuration. A, A and this one. So therefore minus twice epsilon 0 twice epsilon minus epsilon 0 and the epsilon. Sixth possible, this one, this one, this one, this one, that one, this one. So now energy of microstate and the degeneracy. This is the energy and here the degeneracy. Here the energy minus 2 epsilon, degeneracy 1. 2 epsilon is 1, minus epsilon is 1, and the epsilon is 1 and 0 is 2. These are the degeneracy. So now the partition function Q is equal to 2 plus e to the power minus beta e plus e to the power beta epsilon plus e to the power minus 2 beta epsilon plus e to the power 2 beta epsilon. This is the equation number 1. So the average energy that the minus del del beta of ln q, this is equal to minus 1 by q minus epsilon e to the power minus beta epsilon plus epsilon e to the power beta epsilon minus twice epsilon e to the power minus twice beta epsilon plus twice epsilon e to the power twice beta epsilon. This is the equation number 2. Therefore, equation 2 can be written in the form E average minus 1. Put this value minus epsilon into half plus epsilon into 2 minus twice epsilon into half whole square plus twice epsilon 2 whole square. Okay, and the denominator 2 plus half plus 2 by 1 plus 1 by 4 plus 4 by 1. Given that e to the power minus beta epsilon is e to the power minus epsilon by kt, this is the half. So we now get the average value energy that minus 36 by 35e. Okay, that means the n equal to 36. 36 would be the correct answer. And here is written that 36 or 15. Due to a possible alternate interpretation of this question, both 36 and 15 will be treated as a correct answer. For our interruption, we just get 36 because in our accessible microstate of the different, another for the different choosing of the arrangement, it will become the 15. Question number 2. A semi-infinite thin wire exceeding from minus infinity to 0 along z-axis carries the constant current I in the positive z direction. The wire is charged neutral except z equal to 0, where the inflowing charge is accumulated. What is the absolute value of the integral 4 by epsilon naught I integral b dot dl along the circle x square plus y square equal to 1? B is the magnetic field, mu naught permeability in the free space. Assume that the accumulated charge at z equal to 0 is a point charge. Simple. The magnetic field is defined here. B equal to mu naught I divided by 4 pi r phi cap. Simple to the integral over line b dot dl is equal to 0 to twice pi mu naught I, put this value 4 pi r phi cap into, this is the surface element, RD, high phi cap. This is equal to, it would become 4 by mu naught I line integral of the BDL, that would become the 2. Okay, 2 would be the correct answer. Next, consider the rotation matrix. Let phi be the angle of the rotation. What will be the value of the sec square phi? First, simple, that R transpose R, you would get the identity matrix. You do it yourself. So R is what? Orthogonal. So now, determinant of the R, it will also become 1. That means it involves the rotation. Next, the eigenvalue of R would become the lambda 1, lambda 2 and the 1. So we'll write the matrix in the form D equal to C inverse RC. This is the transformation. This is called C inverse RC, the similarity transformation. So now that means the D is equal to, within the matrix, lambda 1, 0, diagonal element are lambda 1, lambda 2, 1. Off diagonal element 0, 0, 0, 0, 1. We compare with the result, cos phi minus sin phi 0, sin phi cos phi 0, and the last one 0, 0, 1. That means, thus, the twice cos phi plus 1, this is the sum of lambda I, this is the equal to trace of R, that is equal to 2/3 plus 2/3 plus 2 by 4, this is the 2. So cos phi equal to 2. That means the value of the sec square phi would be the 1 by 4. 1 by 4, okay. Value of the cos phi equal to half means the sec phi equal to 2. And the sec square phi would be 4. 4 would be the correct answer. Not 1 by 4. 4. Answer 4 would be the correct. Just a minute. Distortion. Okay, now fixed. Here the value to the correct, here 4. Next, the question number 4. Question number 4. And here the answer should be the sec square phi equal to 4. A quantum harmonic oscillator of mass m and the angular frequency omega is in state psi 1 by root 2, this one. N denote the nth normalized energy eigenstate of the harmonic oscillator. Let L naught equal to square root of h cross by m omega. Denote the oscillator size, and xk expectation denote the expectation value of the position operator in the state gets psi. What is the value of x expectation by L naught? You may use the form of the position operator in terms of the raising and the lowering operator. X cap equal to L naught by square root 2 a plus a dagger. L naught by square root 2 a plus a dagger. This is the operator form you may use. This is basically the quantum mechanics. I hint you, you solve yourself. First psi is given here. So let us check that expectation of x, that means just calculate, simple question, psi x psi. Expectation value. You would get 0 of expectation 287 x 287. This is 0 and the 288 x 288. This would be always 0. You calculate it. And similarly, since this is 0, now you do calculate that this is 0 because the normalization, simple, xx. The 287 x 288, this expectation would become L naught by square root 2 root 288. Next, 288 x 288 287, this would become L naught by square root 2 square root of 288. Now the expectation value of x, this is the half of 0 plus L naught by square root 2 root 288 plus L naught by square root 2 root 288. This would become what? L naught into 12. So x naught expectation by L naught. Okay. You have to find this value. Therefore, this would become 12. 12 would be the correct answer. Next question, question number 5. A quantum mechanical particle of mass m is confined in a one-dimensional infinite square potential well whose walls located at x equal to 0 and 1. The wave function of the particle inside the well is psi x is given this form. An experimentalist measures the position of the particle of an ensemble of a large number of identical systems in the same stage. The mean of the outcome is found to be 1 by n, where n is an integer. What is the value of the n? Simple question. So now you just only take the mean position. This is some mathematical or probability concept. So this is for the homework 3. Homework number 3. Solve yourself and feedback me with the answer. Next question, question number 6. A point mass m constant to move along x-axis in under the influence of the gravitational and attraction from 2-point particle each of mass m fixed at the point x equal to 0 y a x 0 y minus a. Find the time period of small oscillation of mass m in unit of pi root over of a cube by 8 gm. This is the universal constant. From the classical mechanics. Here simply that this is the diagram here. This is x 0a 0 minus a, the point. This is the origin 0. Here the angle theta. Here m dash and the m mass. This is the point mass of small m. So now net force acting on m, that F equal to twice fx x component. Put this value of fx. This would become minus 2 z mm by x square plus a square cos theta along this direction cos theta. So F means ma, equation of motion, 2z mm x divided by x square plus a square to the power 3 by 2. That means, or a would become minus twice zm by a cube into x. That means the omega equal to square root of 2zm divided by a cube. Okay. So time period t twice pi by omega. That means 4 pi square root of a cube by 8 zm. It will be the correct answer. So in the unit, this is basically the n pi. That means the n equal to 4. 4 would be the correct answer. Next question. Question number 7. The radial path of the electronic ground state wave function of the hydrogen atom define this equation. If R expectation and RMP denote the expectation value and the maximum probable value of the radial coordinate respectively, compute 8 by 3 R expectation by RMP. Simple. So this is the ground state of the hydrogen atom for n equal to 1. Now let us check that R expectation means, this is a useful formula that I just do here. The R expectation is very important. Half 3n square minus L into L plus 1, very important, into A naught. This is the R expectation general formula. Put this value, you would get 3 A naught by 2. And the R of MP, most probable, that the A naught. Just divide 8 by 3 times of R expectation divided by R of MP. That means the 8 by 3 times 3 A naught by 2 divided by A naught. You would get 4. 4 would be the correct answer. Next, question number 8. A magnetic vector potential is given in the form. Find the corresponding outgoing magnetic flux through the 5 faces of an unit cube with one corner at the origin as shown in the figure. Now, that simple surface integral of B dot dA, this is equal to 0. That implies that surface S1 B dot dA plus net surface rest surface B dot dA, this is 0. That means, that implies that the rest surface of B dot dA equal to minus of integral S1 B dot dA. This is nothing but the integral of S1, the curl of A dA. Okay, curl of A dA. Now the curl of A. Curl of A you calculate. Simple. I J K del del X del del Y del del Z 6 y z square, and here cy plus z. You would get here, this is the 0. Okay, so that means the integral of rest surface B dot dA, this is obviously 0. 0 would be the correct answers. Next, two question. Question number 9 is for homework. This is for homework number 4. And the last question, question number 10. An object of height 10 millimeter is located 150 millimeter to the left, a thin lens of focal length 50 millimeter. A second thin lens of focal length minus 100 millimeter is to be placed to the right of the first lens such that the real image of the object is located 100 millimeter to right of the second lens. What should be the separation in millimeter between the two lenses? This is from the wave and optics. Wave and optics. This is the ray diagram. This is the ray diagram. Okay, here the object. This is L1, L2, this is D, this is I1, this is I2. This distance is 100 unit. This is F2 minus 100 millimeter, and the F1 is positive 50 unit given millimeter. Okay, this is 150, and this is the ray diagram. Simple. So first lens U1 is what? Minus 150 millimeter, and the F2 is plus 50 millimeter. So by the lens equation, 1 by V1 equal to 1 by F1 plus 1 by U1. Put this value, you get the V1 value 75 millimeter. Image I1 will be on the right side of the concave lens because it will act an virtual object of L2, and its real image will be observed on the same side of L2. That means the U2 is what? 75 minus D, and the V2 100. Okay, F2 is given minus 100. Next, again apply the lens equation. 1 by 100 minus 1 by 75 minus D is equal to minus 1 by 100. You would get the value of the D, that the separation between the two lenses, this is you have to find. This would become 25 millimeter. So 25 would be your correct answers. Okay, so we now discuss here and completely solve the JEST 2024 full question paper conducted by ACRB board and IIST Tiruvananthapuram. So I think it will be very useful for solving any problem upcoming JEST 2025 exam. So last but not the least, thank you very much. Stay well and happy.